Institute of Engineering and Technology. So let's begin with the first topic, that is exact differential form. Any expression of the form f1 dx plus f2 dy plus f3 dz is a differential form. Okay, a differential form is exact in a space if f1 dx plus f2 dy plus f3 dz is equal to d of phi for some scalar function phi. Okay, so if there exists phi such that this f1 dx plus f2 dy plus f3 dz is equal to d phi, then we can say that the differential form is exact. Okay, but whenever we have to show that f bar is exact, what we will do, we will find curl of f bar is equal to 0. Okay, so if we can show that curl of f bar is equal to 0, then we can say that the given field f bar is what? It is exact. Okay, now let's discuss one example. Show that the differential form under the integration this is exact in a space and evaluate the integral. Okay, so first we have to show that it is exact, right? So for that we have to show that curl of f bar is equal to 0. Now this integration is what? Here integration is given. Okay, and every time integration is like this, f1 dx plus f2 dy plus f3 dz. Okay, in this form. So first we have to write f. Okay, so what is f? F is what? f1i plus f2j plus f3k. Okay, all right. Now just multiply this inside. Okay, so with dx we have f1. So f1 will be what? E raised to x minus y plus z square I. Okay, with dy. Okay, and this negative sign. So what is f2? F2 is minus e raised to x minus y plus z square. And what is f3? This is 2z into this term. So 2z e raised to x minus y plus z square k. Okay, so this is our f bar. Now we have to show that it is exact, right? So for that we have to show that curl of f bar is equal to 0, right? So now we will find curl of f bar. So curl of f bar, okay, this is what? Del cross f. Okay, and this is I j k. Okay, del by del x, del by del y, del by del z. What is f1? It is e raised to x minus y plus z square. What is f2? Minus e raised to x minus y plus z square. And what is f3? It is 2z e raised to x minus y plus z square. Okay, now this is important example, and make sure that you don't make any mistake using while solving this determinant. Okay, now first we will solve this. Okay, so with respect to y we have to find its derivative. Okay, so it is what? 2z e raised to x minus y plus z square as it is, and the derivative of this term with respect to y will be minus. So here we have minus sign. Okay, minus. Now we have to solve this. So what we have over here? Minus as it is e raised to x minus y plus z square, and again derivative of this term with respect to z is what? 2z. Okay, we have like this, minus j cap. Now we have to solve this with this. Okay, so derivative of this term with respect to x. Okay, so this term will be as it is, and derivative of x is 1, so we will get the same term, that is 2z e raised to x minus y plus z square. All right, minus. Now we have to solve this. Okay, so what you will get? E raised to x minus y plus z square as it is, and derivative of this term with respect to z is what? 2z. So into we have 2z. All right, plus k into. Now we have to solve this. So apply this formula. Okay, so what we will have? Minus e raised to x minus y plus z square minus. Now solve this. So with respect to y derivative, so what you will get? E raised to x minus y plus z square into minus 1, because derivative of y is what? Minus 1. All right, now you can see, just open the bracket. Okay, so here we have a negative sign and this will become plus, so this two will get cancelled. Okay, so this is 0i. Now this 2 will get cancelled, so 0 j. Also this minus minus will become plus and this 2 will get cancelled, so we have 0 k. So this is 0 vector. Now curl of f bar is equal to 0, so we can say that f bar is exact. Okay, so this is exact. Now also we can say that if curl of f bar is equal to 0, line integral is independent of path. Okay, and whenever we have line integral independent of path, we know that this integration f dr will be what? Phi b minus phi a. Okay, so what is our next step is to find scalar potential function phi. Okay, now f is equal to what? Grade phi, right? And what is grade phi formula? Del phi by del xi plus del phi by del yj plus del phi by del zk. Okay, just compare this with f1, f2 and f3. Okay, we know what is f1? Del phi by del x. Compare it, so you will get e raised to x minus y plus z square. Okay, now del phi by del y is what? Minus e raised to x minus y plus z square, and phi by del z is what? 2z e raised to x minus y plus z square. Okay, now we have to just integrate with respect to x over here. Okay, so what you will get? Same answer, phi is equal to e raised to x minus y plus z square plus some constant of y and z. Alright, now integrate this with respect to y. So what you will get? Phi is equal to with respect to s. So you will get same term upon minus 1. Okay, and minus minus will get cancelled. So here you will get plus e raised to x minus y plus z square plus g of some constant of x and z. And now here we have to integrate with respect to what? Z. Okay, so what you will get here? Phi. Now to integrate this, we will use this formula: integration e raised to fx into f dash x dx is equal to what? E raised to fx. Okay, so we have e raised to this fx and its derivative with respect to z is what? 2z. Okay, so derivative is present over here, right? So we have like this: integration e raised to x minus y plus z square and derivative z square is present over here. So answer is what? E raised to fx. So here you will get answer as e raised to x minus y plus z square plus some constant of x and y. Okay, so at last what we have to do? We have to write the scalar potential function from this. Now as you can see, we have only this one term, that is e raised to x minus y plus z square and constant. Okay, so we will write scalar potential function as e raised to x minus y plus z square plus c. Okay, now the line integration f dr is what? Phi b minus phi a. Okay, and integration, in this integration a limit is given, so limit is always from a to b. Okay, so your a point is given 0 minus 1 1 and b point is given, this is 2 4 and 0. Okay, so we have to find this phi b minus phi a. So e raised to, now in place of x we'll write 2. So here 2 minus 4 plus 0. Okay, plus this c minus now phi of a. It is what? E raised to 0. Okay, then minus minus it will become plus 1 over here and again plus 1 plus c. Simplify this, so e raised to minus 2 plus c minus c will get cancelled and here we have plus e square. Okay, so this is your answer for line integral. Okay, so in this example, first we have found out curl of f bar is equal to 0. So we can say that it is exact. Okay, and then after we have to find a scalar potential function phi. Okay, and after finding the scalar potential function phi, we have to apply this formula. This is phi b minus phi a. Substitute the value of b and a and simplify, so you will get your answer. Okay, now let's discuss the next topic, that is flux. Now, if the vector field f bar, this is mi plus nj, is some kind of fluid flow and c is the curve, then the line integration f n cap ds represent the flux f bar through curve C, which is where this n bar is what it is, a unit normal vector to C. Okay, so this line integral f n cap ds, f bar is what, mi plus nj. Okay, and this ds we will write it like this. This is d by I minus dxj. Okay, just multiply this, so what you will get, m dy minus n dx. Okay, so this is your formula to find flux. Okay, now let's use this formula and solve one example. So f bar is given. Calculate the flux f bar through the line segment 30 to 03. Okay. So f bar is given. This is 2i plus 0j. So this is, we have to compare with mi plus nj. Okay. So what is m? M is 2 and n is what? 0. Okay. So what is the formula of flux? It is integral. You can see m dy minus n dx. Okay. So m dy minus n dx. Substitute the value. So 2 dy minus 0 dx. So we have only integration 2 dy. Now we can see that this y component varies from 0 to 3. Okay. So y varies from 0 to 3. Okay. So we can write this as integration 0 to 3 2 dy. Simplify 2y 0 to 3. So your answer is what? 6. Okay, so in this way we can calculate the flux of f bar through the given point. Okay, if f bar is given, just compare it with mi plus nj, substitute over here, simplify, so you will get your answer. So I hope you have understood throughout the session. Thank you for watching.